A warm welcome also from my side. My name is Alexander Boehme. I am a chemist by training, and I'm working at the Helmholtz Center for Environmental Research in Leipzig, Germany. And together with my colleagues, we developed a new chemical method for the identification of potential respiratory sensitizers based on their amino reactivity. Our essay addresses the first step of the adverse outcome pathway of respiratory sensitization, which is the covalent binding to proteins. And here it is important that for the respiratory sensitizer, it is expected that they prefer lysine residues of peptides, or in other words, they preferentially react with amino groups. When it comes to covalent binding to proteins, the direct peptide reactivity assay, or in short DPRA, became an OECD guideline in the last decade, and it characterizes the covalent binding to proteins based on two model peptides. And for skin sensitizers, the DPRA performs quite well. It identifies them based on their reactivity. But when it comes to respiratory sensitizers, the DPRA overlooks many of them because, as you can see on both pictures, they do not show the expected high amino reactivity in the DPRA. So the critical question is now, why are certain respiratory sensitizers not correctly identified by the DPRA? And the answer is quite simple and technical. It's the ammonium acetate buffer, which is used for the lysine DPRA. This buffer can also form an aminonucleophile, which is in turn available to react with the test compounds. And when they react with the buffer, they are no longer available for the envisaged reaction with the lysine peptide. This leads to the observation that the ammonium acetate buffer, the lysine reactivity, or in other words, the amino reactivity of many test compounds, is underestimated by the classical DPRA. So what is our solution for this issue? We first replace the lysine peptide by a labeled amino acid, which is glycine paranitroanilate, or in short, GlyPNA. And we applied this new model nucleophile in our assay, which was initially developed for amino-reactive skin sensitizers. But what we do, so the workflow is very much similar to the DPRA workflow. So we have our test compound, we incubate it together with the GlyPNA in a phosphate buffer at pH 7.4. And please note that this is actually the same buffer that is used for the DPRA in the cysteine setup. And after 24 hours of incubation, we do a very simple HPLC UV-Vis readout, which allows us to calculate the reactivity of the test compounds in terms of a % depletion. How did we test our new assay? So we selected known respiratory sensitizers from reference lists in the literature. And in addition to that, we also selected respiratory non-sensitizers. These were compounds that were, for example, classified as respiratory non-sensitizers in one of the reference lists, but also by other reviews in the literature. And based on this little data set, we analyzed the performance of our assay. And here are the results. And on the left side, you can see that with our GlyPNA assay and the phosphate buffer setup, almost all respiratory sensitizer show a very, very high amino reactivity, while the respiratory non-sensitizers are typically less amino reactive. In contrast to that, with the DPRA setup and the ammonium acetate buffer, it's almost impossible to discriminate between potential respiratory sensitizers and respiratory non-sensitizers because in both groups, the reactivity spans over almost the same range. To give you an idea about the predictive performance of our assay, we also analyzed some other compounds from the reference list of Grotz et al. And here in this little table, you can see that almost all respiratory sensitizers from this publication, which can you see here also in this little list, are correctly classified by our assay. Only one is not identified as a respiratory sensitizer, and this is the piperazine. And piperazine as such is not reactive, but it needs some metabolic transformation to become reactive and to become a respiratory sensitizer. But this transformation cannot be mimicked by our assay, but this is not unexpected. This is a very general problem or a known issue with the in-chemical methods. But as you can also see on the table, many of the non-respiratory sensitizers are correctly classified as non-respiratory sensitizers. A very similar result was observed when we had a look on another reference list, which was from Sadika and colleagues. And here our assay classified many of the high evidence respiratory sensitizers correctly. Only 3 were not recognized by our assays, and which are, for example, again, the piperazine as a non-reactive respiratory sensitizers, and another one which is ethylene diamine, and it's also the same as for piperazine. It's not directly reactive but needs metabolic activation. But all, or at least many of the direct reactive respiratory sensitizers were correctly classified by our assay. Okay, let's recap. So our assay is not completely new, but it's an improved DPRA protocol, and it allows you to identify known reactive respiratory sensitizers. It addresses the first step of the AOP of respiratory sensitization, so the covalent binding to proteins, and together with other in vitro methods, it can be used in an integrated testing strategy to assess the respiratory sensitization potential of chemicals. It is a non-animal approach, and as such, it is in line with current regulatory priorities. The only thing which cannot be done with the assay is the assessment of those compounds that need some kind of metabolic transformation, because this cannot be mimicked by our assay. And with that, I would like to thank you for your attention and hand over to the next speaker. Thank you very much.